Ukmt IMC 2018 from number 11. Let's start. Here diagram shows a regular hexagon, so many hexagons in this exam. So now we understand this is a 60 degree and 30 degree. So let's say if we say here x, then this is square root of 3x and 2x. And total shaded area is 20. So because this is 2x, this should be 2x because this is a regular hexagon. So 2x again square root of 3x. So the shaded region, the area is square root of 3x squared over 2, which is a triangle, plus the rectangle 2 square root of 3x squared. So altogether 2 5 square root of 3x squared. So this is 20. So now we understand for x squared is 40 square root of 3, 8 over square root of 3. The question is the area of the hexagon, so whole area. So now we will solve it out. Now we have this triangle 1, 2, 3, 4. We have these 4 triangles and 2 rectangles. So when we solve it, 2 square root of 3, 4, 6 square root of 3 x squares. So now we have x squares here, so 48. Number 12. Someone has switched the number around Harry's calculator. So now it was from left to right, but now it changes from right to left. Will not give the correct answer. Harry used this calculator. So it should be the same calculation before and after. So for example, 79, we click here and here, but when we click the, because it changed it, it will recognize it as 97. So 97 and 79 is the same. So A, correct. 78 and 98, correct. 147, 369, correct. 123, 321, correct. 159 is equivalent to 357. So this is not correct. Number 13. 2 sizes of regular hexagon, which is 160, 120, and 120, which means here 60. So ratio of the area of the smaller hexagon to the area of the larger hexagon. Okay, so this is rhombus, which means this and this is the same. Okay, so actually this is not about the angle. So if this is x, then this could be x because this is rhombus who has all equal sides, 4 sides, which means that this is smaller and larger. The ratio of the length is 1 to 2, which means the area ratio is 1 to 4. 9 and 10 and 10 and 9, so 90 and 190, 81, so 181. So 2 plus 1 over 90, so 2 comma something. So 90 is we have 1 repeated one and 1 non-repeated one. So here I think this could be the answer because there is no other non-repeated the decimal here. So 2 plus 90. So here, because already I exclude 2, so 0.01, the recurrence only on 1. So 0.1 minus 0, which is 1, which is this one. So this is the answer. How many of these bowl shapes could be the shape of the region where 2 triangles overlapped? So when 2 triangle overlaps, for example, so now equilateral triangle, I think we can make it when we have 2 equilateral triangle. Let's say this can be equilateral triangle if we make this and this the same. And square, if we make two right triangles overlapped, then we will make square. Regular pentagon, regular hexagon, it doesn't look very much possible. I mean hexagon, but pentagon, let's say 3 and how can we make it? If we overlap like this, for example, like this, 1, 2, 3, 4. This is still but if just I made it by mistake, but I can make like that. So for example, like this, 1, 2, 3, 4, 5. And regular pentagon has one side is 108 degree. So if we make this 108, this can be at the part of the, let's say like this. This is 108 degree, and if we can make this or same, then maybe we can make it same. I guess so. But regular hexagon, so if I push this up, let's say 1, 2, 3, 4, 5, 6. Ooh, we will make regular hexagon. Okay, so in this case we can make all the shapes here. Number 16. Diagram shows a triangle edges 3, 4, 6 stacked to 1 row. Total shaded area. When we call this alpha, beta, and gamma, the measurement of the angle, alpha plus beta plus gamma is 180 degree, which is the area of the sector here, here, here. When we add them together, it is like a semicircle. So this, actually it is three circles, but we need to exclude half semicircle, like a semicircle, half of the circle. So pi r squared, but it is 1, so pi, but we have 3, but we need to exclude the semicircle, which is, so 2.5 pi. How many 3-digit numbers are increased by 99? Their digits are reversed. So let's say A, B, C. So these are the numbers. But there is one constraint here. A cannot be 0. C cannot be 0 because we need to reverse them. So here, when we expand them, 100A plus 10B plus C should increased by 99 could be the reversed number, 100C, 10B plus C, A. So 10B, so here, A 99A minus 99C equals negative 99. Oh, so A minus C equals negative 1. So A should be 1 less than C. For example, 1 and 2, 2 and 3, let's say 8 and 9. So there are 8 pairs for A and C. But in terms of B can be any number from any digit from 0 to 9, so which has 10 different ways. So 8 times 10, which is 80. Number 18, regular pentagon, equilateral triangle, so 60 and 108, and square X. Okay, number 18. So this is a pentagon and equilateral triangle which has 108, 72, square 90, 90, because this is 102. This is 2, 5, 2 to make it 360. And this is 102 and this is 60, which means this is 192. So let's say this is anyway 1, 2, 3, 4, 5, 6. This is hexagon. So when we see the regular hexagon, which is easiest one for us, one side is 120. So all the sum of all internal angles are 720. So 720 is from here to counterclockwise, clockwise, 72, 90, 90, x, 192, 252. It makes x 180, 16, 25, 41, 6, 695. $180, 1, 2, 3, 4, 5, 6, 3, 2, 6. So 6, 9, 6, 24. So 19, same area. So x, y is x plus 4, y minus 3 equals x plus 8, y minus 4. xy, 4y minus 3x, 12. xy, 8y, 4x, 32. So let's call 1, 2, 3. Let's say 1 equals 2, and we can simplify 4y minus 3x. And 1 equals 3, we can simplify 32 equals 8y minus 4x. Let me divide by 2. 16 equals 4y minus 2x. And when I calculate it, negative 4 is negative x, so x is 4. When x is 4, 8, 24, y is 6. So when we add them together, 10. Number 20, particular integer is smallest multiple of 73, which of whose digits is either 0 or 1. How many digits does this integer have? Okay, so 0 or 1, which means we need to like use this, express this as the multiple, no, I mean prime factoring. So 9 times 8, so 2 to the power of 3, 3 to the power of 2. So when we multiply something here, this should be have 0 or 1. So let's say if it has 5 times 3, this makes 3 times 2 and 10 times 3, which make it helpful. But the problem is 3 times 2 doesn't make any, it cannot make any, I see, because the 9 should make something, this number 1 or 0. So this should be multiple of, okay, now I understand. This should be multiple of 9. So now we know 1, 2, 3, 4, 5, 6, 7, 8, 9. But this is not the multiple of 8. This is 8 and 9, because 8 should be the last 3 digits, should be multiple of 8. So 100 is not multiple of 9, right? 8. So we need to make the last 3 digits should be 3 zeros. So this all has 9 of 1 digit and 3 of 0 digits. So altogether 12. Number 21. Certain values of x plus 6 and x squared, just 2 different numbers. So which means x, for example, x and x plus 6 can be equal, or x and x squared can be equal, or x plus 6 and x squared could be equal. So in this case, cannot be true. So in this case, x could be 0 or 1. So let's say if it is 0, this is 0, 6, 0 makes sense. 1, 1, 7, 1 makes sense. So 0 and 1 can be the answer. So this one, x squared minus x minus 6 equals 0. So x can be 3 or negative 2. When x equals 3, 3, 9, 9 makes sense. Negative 2, 4, 4 makes sense. So we have 4 different x's here. Number 22. 3 squares, side length 2, L shape. All 5 vertices are okay, rectangle, one of midpoint at the edge. Okay, so what is the area of the rectangle? So this side length is 2 and 2. So we know this is 2 square root of 2 and 2 square root of 2. Because we know the ratio of this right triangle, right isosceles triangle. And because this is 2, this should be square root of 2. And this is 2 square root of 2. Which means the length is 4 square root of 2 with 3 square root of 2. So 24. So number 23. This is hexagon whose all interior angles are 120, but not regular hexagon. And some are like this, but we don't know the area of the hexagon. Actually, we know hexagon not always, because of this 120 degree. It is very close to this equilateral triangle. So now, because this is 120, 120, if we extend the two sides like this, this could be the equilateral triangle. This and this, and this and this. And same like here, let's say. And this one, 1 and 1, 2 and 2. So this is 5 and 5. And this is 10. And this is 60, this is 60. So this should be 60. So, okay. This is 5 and 5. So in this case, we can find the largest equilateral triangle and subtract these 3 smaller ones. Then we know the formula, square root of 3 over 4, a squares, 10 squares, minus 5 squares, minus 1 squares, minus 2 squares. So 125, 1, 4, 30, which means 70. So square root of 3 over 4 times 70. Oh, there's no answer. Wait. Sorry, this is 11. This is 11. So 11. So that is not 5. This is 6. Sorry, 6. So here, one 21, 36, 1, 4, 40, 80. So this is for 80 and 20 square root of 3. List of 5 positive integers has mean 5, mode 5, median 5, range 5. How many such a list of 5 positive integers are there? So we have 5 in the middle. And enlist 2 5s here, let's say. And range 5 and mean 5. So A, B, C, let's say. A plus B plus C, this is like ascending order, plus 10 over 5 is 5, 15. So when we add them together, this should be 15. And also C minus A should be 5. So C is a 5 plus A, so very dependent. So A plus B plus 5 plus A is 15. So 2A plus B should be 10. So let's say if A and B need to be smaller or equal to 5, because this is ascending order. So let's say, no, actually A, 5, 5, B, C can be also possible. So let's not make the B any constraint. So like this. So here, let's say if A is 1, B can be 8. But C should be 6, doesn't make sense. A is 2, 6, 7 makes sense. 3, 4, 8 makes sense. And 4, 2 doesn't make sense because there are 2 lists on it. Let's go to number 25. And here there are between 2 equilateral triangles, and the difference is square root of 3 here. Let's say here is a square root of 3, and because this is the equilateral triangle, this is a 30 degree, which means that this is a 2 square root of 3, and this is 3 because of the ratio. So which means that this is also 3. This is a square root of 3, and we don't know this one yet. So this is a square root of 3. Let's say if we consider this x, then this is a square root of 3x, and this is 2x. What do we need to know? So which means that this is 2x. So now we can make the calculation, like a ratio, because this one is a special right triangle which has 30, 60, 90 degrees. So the 2 square root of 3x, 2 square root of 3 plus square root of 3x plus square root of 3 over, this is a larger one, over the hypotenuse is 6 plus 2x. This should be square root of 3 over 1. Is it? Square root of, no, because this is the the hypotenuse, so this should be 2, and that is the opposite of 60, so this should be square root of 3. So now we can do this cross multiple, then 6 square root of 3, 2 square root of 3x is 4, this is a 3 square root of 3, so 6 square root of 3 plus 2 square root of 3x. Oh, this doesn't solve. Okay, then if this doesn't work, we will do another one. So what is the question? Okay, actually we've solved it. So difference between the lengths of the edges of the two triangles. So larger triangle edges is like 6 plus 2x minus the smaller edges is 2x. So this is a 6